Welcome back, curious minds, to the Sleepy Narrator. If you've drifted here tonight, it's likely you're searching for peace, for rest, or for a chance to let your thoughts wander into something gentle and intriguing. You've found the right place. This evening, we begin a journey into remarkable corners of the natural world, into creatures and organisms that live in ways that seem almost impossible. These beings remind us of life's astonishing adaptability, existing where we would expect nothing to survive. As your eyes grow heavier and your body relaxes into stillness, let your mind travel with me as we step softly into the world of extremophiles, organisms that flourish in environments most would call unlivable. They thrive in heat that boils water, in cold that turns the earth to stone, in acid strong enough to eat through metal, and in radiation that would kill us instantly. To understand them is to glimpse the endurance of life itself. So get comfortable, whether tucked beneath warm blankets, resting on your couch, or lying back in quiet ease. Tonight, we'll wander together into a realm where what seems harsh becomes a sanctuary, and what seems impossible becomes reality. Our story begins with one of the most extraordinary creatures ever discovered, the tardigrade. Known affectionately as the water bear or sometimes the moss piglet. It is a microscopic being, no longer than a millimeter, that has fascinated scientists for generations. Under magnification, it appears plump, with stubby legs ending in small claws, giving it an oddly endearing look. Despite its almost toy-like appearance, it is one of the toughest life forms on Earth. Tardigrades can endure conditions that no human or animal could hope to survive. They have been frozen, boiled, starved of oxygen, blasted with radiation, dried out for decades, and even launched into space's vacuum. Each time when conditions improved, they returned to life as if nothing had happened. Their secret lies in a remarkable process called cryptobiosis. When threatened by environmental extremes, tardigrades draw in their legs, curl into a tight ball, and shut down nearly every biological function. In this state called a ton, they are almost completely inert, able to last for astonishingly long periods. Once conditions stabilize, when a single drop of water touches them, they revive, unfolding their tiny limbs and continuing life as though time itself had paused. On a molecular level, tardigrades protect themselves with unique proteins and sugars like trehalose, forming a protective shield around their DNA and cellular structures. These natural defenses make them nearly indestructible. For many scientists, tardigrades are a symbol of life's stubborn persistence, a reminder that survival often comes not from strength or size, but from the ability to adapt. But the tardigrade is only the beginning. Beyond it, the microbial world holds many more extremophiles, each designed for conditions that would obliterate almost anything else. Consider the thermophiles, microorganisms that flourish not in warmth, but in searing, boiling heat. They are found in hydrothermal vents at the ocean's floor and in the hot springs of Yellowstone-like landscapes. Where most proteins would collapse and unravel, theirs remain strong. Many live best at temperatures of 80 to 120 degrees Celsius, and some even higher. For perspective, water at sea level boils at 100 degrees Celsius. Among the most celebrated of these organisms is Thermus aquaticus. From it, scientists extracted an enzyme called Taq polymerase. This single enzyme transformed biology forever because it enabled the process known as polymerase chain reaction, PCR. PCR allows scientists to replicate DNA sequences again and again, quickly and reliably. It has become indispensable in medicine, genetics, and forensics. From medical diagnostics to criminal investigations, discoveries once thought impossible became routine, all thanks to a microorganism living in boiling water. Just as astonishing are halophiles, the salt lovers. These organisms exist in briny lakes, salt flats, and deep mines where the salt concentration is so high it would draw water out of most cells until they shriveled. Instead of dying, halophiles thrive. They use specialized pumps and proteins to balance the overwhelming salt in their environment while still keeping themselves hydrated. Some even produce rich pigments, reds and purples, that paint entire lakes in vivid colors, visible from the sky. These pigments protect them from the sun's radiation while giving their homes an unearthly beauty. From salt, we turn to acid. Acidophils are organisms that flourish in low pH environments, where the water is as acidic as battery acid. Found in mine drainage, sulfur springs, and volcanic vents, they resist conditions that would instantly burn human skin. They survive by carefully controlling their internal chemistry, keeping their own cells neutral while everything outside is hostile. To them, acid is not a threat, but a source of energy, something to be harnessed for growth. On the opposite end, alkaliphils prefer extreme bases, thriving where the pH rises above 10 or 11. Soda lakes, rich in carbonates, are their favorite dwellings. Just like their acidic counterparts, they maintain balance within while the world outside challenges survival. For industry, they are valuable, as their enzymes perform in high pH conditions like those inside detergents. Radiation is another enemy most living things cannot withstand. But there exists a bacterium called Deinococcus radiodurans, nicknamed Conan the bacterium. It survives radiation thousands of times higher than the lethal dose for humans. How? By repairing its DNA with extraordinary precision. When radiation shatters its genetic material into pieces, this organism methodically reassembles the fragments, as though stitching a torn book back into perfect order. It is nearly indestructible, not only against radiation, but also against dryness, heat, and toxins. For scientists, these extremophiles are more than curiosities. They are windows into the deep past, when Earth itself was hostile, its oceans acidic, its skies filled with volcanic gases. Life began in such conditions, and by studying these resilient organisms, researchers gain glimpses into how our earliest ancestors survived. And perhaps just as importantly, extremophiles guide us toward the future. If life thrives in boiling vents, frozen ice, or deep within rocks, then perhaps it could also exist on other worlds. Mars, Europa, and Enceladus, planets and moons once thought barren, might hide microbial life, clinging to extremes. Astrobiologists use extremophiles as models, expanding the search for life beyond Earth. They remind us that life does not require comfort. It requires possibility. As you drift deeper into rest, consider this. Somewhere far beneath the waves, a thermophile feeds on minerals near a volcanic vent. In a glowing salt lake, halophiles color the water red beneath the sun. And in abandoned tunnels, acidophils float peacefully in liquid that would corrode steel. They are not monsters. They are miracles. And they are proof. Life will always find a way. The idea of life enduring against impossible odds continues to shape how we understand our world. The organisms we've spoken about so far, tardigrades, thermophiles, halophiles, and others, prove that existence is far more flexible than we once believed. But to truly grasp how extraordinary these beings are, we must look deeper into the relationship between survival and adaptation, and how life reshapes itself to endure. Imagine, for a moment, the deep ocean floor. It is a place utterly cut off from sunlight, with pressures so immense that human-built submarines groan under the strain. And yet, scattered across this black landscape are hydrothermal vents, spewing superheated water laced with minerals. At first glance, this environment appears lethal, boiling fluids, no light, crushing weight. But instead of emptiness, these vents host rich communities of extremophiles, including bacteria and archaea that thrive through chemosynthesis. Unlike plants, which use sunlight to create energy, these organisms draw sustenance from chemicals like hydrogen sulfide released from the vents. From them, entire ecosystems bloom: tube worms with crimson plumes, shrimp with reflective shells, and crabs that pick along the rocky edges. Life, instead of being erased, has built new strategies for flourishing. This idea, that even in the most unforgiving corners of Earth, something adapts, gives hope that alien worlds, too, may not be empty. It tells us that the conditions for life are not as narrow as once assumed. They stretch, bend, and evolve, becoming wider with every discovery. Let us turn now to organisms that live not in boiling water but in ice. Psychrophiles are extremophiles that love the cold. They are found in polar seas, glaciers, and frozen soils. To us, such conditions mean numb fingers and stiff joints, but to psychrophiles they are home. Their enzymes and membranes are carefully designed to remain fluid and flexible at freezing temperatures. If those same cells were warmed to our body temperature, they would unravel. For them, warmth is deadly, and ice is comfort. Scientists have uncovered psychrophiles beneath thick Antarctic ice sheets, in places untouched by sunlight for millions of years. In those frozen lakes, sealed beneath ice, these organisms persist quietly. Some scientists believe such hidden habitats mirror environments on moons like Europa, where thick ice covers vast oceans. The endurance of psychrophiles may be our closest guide to what waits beneath alien ice. While cold may seem gentler than heat, surviving it is no less impressive. Psychrophiles prevent their cells from freezing solid by producing proteins that act like antifreeze. These special molecules stop dangerous ice crystals from forming inside their bodies. In this way, they resist a slow death by freezing, existing instead in a delicate balance with their icy world. The more we learn, the clearer it becomes. Extremophiles do not merely survive. They transform the concept of life itself. To them, extremes are not barriers, they are foundations. But life is not always about adapting to one element. Some extremophiles endure several. There are polyextremophiles, organisms that withstand multiple hostilities at once. Consider microbes in the deserts of Atara, a land where days are blistering, nights are freezing, and water is almost non-existent. These microbes face heat, cold, dryness, and radiation simultaneously. Yet they endure by hiding inside rocks, shielding themselves from sunlight and conserving every drop of moisture. Such organisms remind us that adaptation often requires versatility. Where one strategy is not enough, they build several. They are survivalists in the truest sense, beings that have mastered not one extreme but many. Let us pause on the word survival. Often, we think of it as barely scraping by, clinging to life against odds. But for extremophiles, survival is not simply endurance, it is thriving. They grow, reproduce, and create new generations within environments that to us are nightmares. Their version of normal defies our imagination. One of the most curious lessons they teach us is that life finds ways to rewrite its own rules. DNA, for instance, is normally fragile, easily damaged by radiation or chemical stress. Yet in extremophiles, new repair systems have evolved. New molecules protect fragile structures, and new methods of energy production emerge. In many ways, extremophiles are pioneers of biology, constantly testing and expanding what is possible. Their resilience is not only fascinating but also practical. Industries now use extremophile enzymes in processes that would destroy ordinary proteins. From detergents to biofuels, from food production to medicine, their gifts are woven into our daily lives. A single protein from a heat-loving bacterium has changed how we diagnose disease. Another, from a salt-loving microbe, strengthens chemical production. And still others may help crops survive harsher climates. Even in space exploration, extremophiles play a role. When researchers consider sending humans to Mars or building colonies on icy moons, they study extremophiles for clues. How can cells resist radiation? How can they endure limited water? How do they survive on chemical energy instead of sunlight? The answers, often, are hidden in these small but mighty organisms. Perhaps the most profound revelation extremophiles offer is this: fragility and strength are not opposites. They coexist. These creatures are small, often invisible, Yet their ability to live in hostile conditions surpasses our greatest machines. Their existence is a quiet defiance, a whisper that life, no matter how small, always seeks a way forward. Now, as you drift deeper into calm, picture this. Beneath miles of Antarctic ice, a psychrophile divides slowly, continuing a cycle older than empires. In a desert cave, a polyextremophile nestles inside rock, safe from heat and radiation. And in boiling vents, thermophiles gather energy from gases, building communities in total darkness. They are everywhere, hidden in silence. And they remind us that life is never limited to comfort. It flourishes in challenge, proving again and again that possibility is enough. So let these thoughts linger as you rest. The world is stranger, tougher, and more miraculous than we often believe. And if life can thrive in acid, in radiation, in ice, and in boiling depths, then perhaps, just perhaps, hope is always possible, even in the harshest of places. The world of extremophiles is vast, but their true meaning becomes clearer when we understand what they reveal about existence itself. Each of these organisms shows us that life is not fragile glass, easily shattered. It is more like water, shifting, bending, and adapting to the container in which it is placed. To witness their survival is to watch resilience take shape in endless forms. Consider for a moment the volcanic craters that dot the surface of the land of Thalura. Here, geysers erupt with clouds of sulfur, and pools of acid shimmer with toxic brightness. Most living creatures would perish instantly if they touched those waters. Yet, thriving within them are acidophils, tiny but determined organisms that see this hostile brew not as a barrier but as nourishment. What is poison to us is sustenance to them. Where we see destruction, they find opportunity. This inversion of perspective is one of the most profound lessons extremophiles offer. Danger, when understood and adapted to, becomes survival. The same is true in the alkaline lakes of Solera, where the water is so caustic it would strip skin. Yet, alkaliphiles find joy there, turning chemical imbalance into balance. Their enzymes and proteins are so finely tuned that they operate best in conditions that unravel nearly every other form of life. To them, it is not extremity, it is home. Now, let us descend into a salt flat at dusk. The ground is hardened and white, crusted over from years of evaporation. Pools of water shimmer like mirrors, reflecting the sky. And within them, halophiles glow, painting the water crimson and violet. Entire landscapes are transformed by their pigments, becoming surreal and dreamlike. Here again, extremophiles are not hidden, they are artists, reshaping the environment itself with their colors. But not all extremophiles are so visible. Some hide deep underground, buried within rocks. Endoliths, organisms that live within stone, exist far from sunlight, nourished only by trace minerals and water droplets that seep through cracks. Slowly, silently, they persist, etching out survival in places where time seems to stand still. To imagine them is to realize that even in what appears lifeless, something may stir. These stone dwellers remind scientists of planets like Mars, where surface conditions are harsh but the subsurface may hide secrets. If life can burrow deep into rock here, why not elsewhere? Each discovery pulls our vision further outward, from our own soil to the stars above. Another marvel lies in desiccation-tolerant organisms, those that endure extreme dryness. They can lose nearly all their water content, a state that would spell death for most life. Yet, by producing protective sugars and proteins, they wait patiently for moisture's return. Years may pass, even decades, and when rain falls or dew gathers, they stir back to life. For them, dormancy is not an end but a pause, a kind of suspended animation where survival waits quietly for the right moment. This ability fascinates scientists searching for methods to preserve food, medicine, or even human cells for long durations. The lessons extremophiles teach are not only about endurance in nature, but also about tools for our future survival. Radiation-resistant organisms, too, are more than curiosities. They may help us clean toxic waste, protect astronauts from cosmic rays, or even inform cancer treatments. What seems like a strange anomaly becomes a doorway to human innovation. Extremophiles also remind us that life is not limited by our imagination. For centuries, humans defined habitable as conditions comfortable to us, oxygen-rich air, mild temperatures, and sunlight. Yet time and again, extremophiles expand the definition, showing us that habitability is far broader. It is a spectrum, not a narrow window. Take, for example, the polyextremophiles of the frozen deserts. In places where dryness, cold, and radiation combine, they flourish still. Their strategies are diverse: pigments that block radiation, shells that retain water, and enzymes that remain flexible in cold. By combining adaptations, they survive where no single trick would be enough. It is this creativity of survival that is most awe-inspiring. Extremophiles are problem solvers, each one carrying a different key to a different lock. Collectively, they form an encyclopedia of solutions to nature's hardest challenges. And in this encyclopedia, there is something else: history. For extremophiles are often thought to resemble the earliest life on Earth. Our planet's young days were filled with volcanoes, acidic seas, and thin oxygen. To imagine the first organisms is to imagine extremophiles, simple yet stubborn, carving out life in a hostile world. In their resilience, we may glimpse the story of our own beginnings. This connection between past and present extends outward as well. If life here began in extremes, then life elsewhere may also favor them. That is why astrobiologists look to icy moons, barren deserts, and deep oceans with curiosity. They ask, if life exists beyond Earth, will it resemble the organisms we once dismissed as strange? Every discovery strengthens this possibility. Beneath Antarctic ice, we find microbes alive in ancient lakes. In the driest deserts, life clings to shadows of stone. Even in radioactive pools, cells thrive. The message is clear: do not underestimate the persistence of life. And so, as you breathe gently and your body rests, picture these small wonders. In sulfur pits, acidophils shimmer. In soda lakes, alkaliphils whisper. In rocks beneath your feet, endoliths persist in silence. Each one proves that the definition of home is vast, bound not by comfort but by creativity. The story of extremophiles is not just about survival, it is about possibility. They remind us that no matter how harsh the environment, there may be a way forward. Their resilience echoes in our own struggles, whispering that endurance is always possible. So tonight, as you drift into deeper calm, carry this thought with you. Life is a patient sculptor. It shapes itself against fire, against ice, against acid and stone. And in doing so, it reveals a truth both simple and profound. Existence does not need ease. It only needs a chance. The tale of extremophiles is more than a catalog of oddities. It is a mirror reflecting the boundless inventiveness of life. To walk through their world is to step into a library written not with words, but with resilience, each page telling us how existence refuses to surrender. Let us travel now to the frozen highlands of northern Velmira, where ice lies heavy on the land, and winds howl across glaciers like whispers from ancient ages. Here, psychrophiles thrive, organisms whose very essence depends on the cold. While most cells crack and rupture when frozen, these beings have perfected survival by producing antifreeze proteins, preventing ice crystals from forming inside their fragile structures. Instead of shattering, they bend. Instead of dying, they endure. For many, the thought of being trapped in such lifeless cold brings visions of silence and stillness. Yet psychrophiles prove that beneath those layers of frost, an invisible rhythm beats. Life continues, quietly, patiently, always waiting for the right moment to stir. Now imagine the deserts of Kareth, vast and dry, where the earth itself seems to sigh with thirst. In these wastelands, desiccation-tolerant organisms live without water for years, sometimes decades. They shrink into dormancy, folding their functions inward, protecting their DNA with sugars and proteins that serve as shields. When the rare rain finally falls, these organisms awaken, stretching back to life, as though a long-held breath has finally been released. It is not only survival, it is a demonstration of time's flexibility. While we measure life in constant rhythms, heartbeats, breaths, days, these organisms reveal another possibility. Life can wait. It can pause, curl itself into stillness, and awaken long after the world has changed. Such resilience echoes in the salt marshes of Serath, where halophiles continue their quiet work. Their pigments color entire waterscapes in scarlet, lavender, and violet, turning desolate plains into canvases. Travelers describe these places as otherworldly, landscapes where Earth itself seems painted by a giant hand. And indeed, halophiles remind us that even at microscopic levels, life leaves beauty in its wake. These pigments are not only art, they are protection, filtering harmful sunlight, guarding fragile cells, and converting energy. What we see as striking color is, to them, survival in motion. Extremophiles also remind us of resilience beneath pressure. Deep within the oceans of Vaynar, where darkness reigns eternal, pressure would crush ordinary beings. Yet pisophiles or barophiles thrive here in the crushing depths. They are adapted to conditions so intense that to bring them to the surface is to kill them. Their proteins and membranes function only under the heavy hand of the deep sea. For them, the ocean's crushing embrace is not a prison but a home. In these abyssal zones, vents spew mineral-rich fluids, feeding not just microbes but entire ecosystems. Fish with glowing organs drift by, crabs with pale shells scavenge, and tube worms extend their brilliant plumes. All of it depends on the chemosynthetic microbes at the base of the food chain, extremophiles that turn poison into nourishment. The picture painted here is one of balance. Where destruction seems inevitable, creation begins. Where nothing should live, life thrives. Even in places touched by radiation, life finds a foothold. The story of Deinococcus radiodurans, Conan the bacterium, reminds us of this truth. Its genome can be shattered into fragments by radiation 1,000 times stronger than what kills humans. Yet, it reassembles itself with such accuracy that life continues. To imagine this process is to imagine a book torn apart, every page shredded, and then perfectly reordered, word for word, as if no damage had ever occurred. This astonishing resilience challenges our understanding of mortality itself. What does it mean for life to end, if it can come back from conditions so absolute? For extremophiles, endings are often temporary. Survival lies not in avoiding harm, but in repairing it with remarkable skill. It is here we see another lesson. Adaptation is not avoidance. Extremophiles do not flee from extremes. They do not hide or wait for safer conditions. Instead, they embrace the hostile and shape themselves around it. Heat becomes their fuel, acid becomes their breath, pressure becomes their balance. Survival is not resistance but transformation. The more closely scientists study them, the more revelations emerge. Industrial chemistry has borrowed their enzymes to withstand harsh conditions. Medicine looks to them for solutions in healing and preservation. Agriculture explores their resilience for crops that may one day endure harsher climates. Every adaptation, every unusual survival trick, becomes a tool we can use to meet our own challenges. Yet beyond science and industry, their story is also deeply philosophical. Extremophiles show us that fragility and endurance coexist. Something as small as a bacterium, invisible to the eye, can withstand what would destroy civilizations. Strength does not always roar. Sometimes it whispers quietly beneath ice, within stone, or inside a drop of acid. And so, when we look to the cosmos, extremophiles travel with our imagination. If Mars holds underground lakes, could psychrophiles endure there? If Europa hides oceans beneath its ice, could chemosynthetic life thrive in its depths? If Enceladus spews plumes into space, could traces of life cling to those frozen waters? Our search for extraterrestrial existence is guided not by human comfort but by extremophile persistence. They are models, blueprints, and reminders that life's requirements may be far less narrow than we once believed. As you rest, let this image settle into your thoughts. In a frozen cavern, a psychrophile clings to ice, its enzymes still moving. In a parched desert, a desiccated cell waits, folded tightly, ready for the rain that will awaken it. In the ocean's crushing blackness, pisophiles drift, sustained by minerals from the Earth's hidden fires. And deep inside a glowing salt pond, halophiles turn the waters into crimson glass beneath the sun. Everywhere in silence, life whispers the same message. Survival is endless. And in that message, we find reflection, not only of what life is, but what it could become. Life, in its quiet determination, often teaches us more in the extremes than in the comforts. The existence of extremophiles is a reminder that where we see limits, life sees opportunity. And in this truth, we find both wonder and humility, an acknowledgement that our understanding of the world is still unfolding. Let us begin with the idea of silence. Imagine the underground caverns of Drosmer, where tunnels stretch endlessly, cut by ancient waters long gone. Here, in the absolute darkness, microbes known as lithoeutrophs draw their energy not from sunlight or organic matter, but directly from the minerals around them. They metabolize iron, sulfur, or hydrogen, eking out survival in stone. In the absence of light, they illuminate the idea that energy lies everywhere, waiting to be tapped. These organisms may be among the closest mirrors to early life on Earth. Long before plants captured sunlight and animals roamed the land, microbes like these likely thrived, hidden in shadows, drawing power from the very bones of the planet. In them, we see echoes of origins, life not as we know it but as it once began. Travel now to the steaming geysers of Kelmira, where boiling waters erupt from cracks in the ground, painting the air with mist. Thermophiles dominate here, their proteins built to resist unraveling under immense heat. Some even require temperatures so high that ordinary life would perish instantly. For them, boiling water is not a hazard but a necessity. Their presence is not only remarkable, it is revolutionary. From a single heat-loving bacterium, scientists extracted an enzyme called Taq polymerase. This enzyme became the foundation of the polymerase chain reaction, or PCR, a method that changed biology forever. From diagnosing illness to solving crimes, from exploring ancestry to studying evolution, PCR has become indispensable. And all of it was made possible by a humble organism in boiling water. The lessons extend further still. Acidophils, those that flourish in acidic pools, show us how membranes and molecules can be strengthened to withstand near-corrosive environments. Alkaliphils, on the other hand, thrive in waters so basic they would strip proteins apart. Both extremes, acid and alkali, reveal that life is not fragile chemistry balanced on a knife's edge. Instead, it is adaptable chemistry, bending rules and rewriting limits to endure. Even radiation, one of nature's fiercest destroyers, cannot silence all life. Organisms such as Deinococcus radiodurans take damage that would shred human cells beyond recognition and repair it with near perfection. Their DNA repair systems act like master builders, reconstructing broken strands as though no harm had ever been done. Such endurance opens doors for humanity. Could crops be engineered with the resilience of extremophiles? Could medicine borrow their resistance to stress? Could space travelers carry their secrets as protection against cosmic rays? The possibilities are vast, and extremophiles continue to whisper answers. But while their practical benefits are many, their philosophical gifts may be greater still. They remind us that definitions of habitability are not absolute. What we call barren, they call abundant. What we see as impossible, they transform into daily life. Their very existence urges us to broaden our imagination. Take, for instance, the icy moons circling faraway planets. Beneath their frozen crusts may lie oceans warmed by internal heat. If extremophiles can survive beneath glaciers here, why not there? If they can metabolize minerals in rock, why not within alien stone? Each extremophile discovered on Earth makes the stars feel less empty, each one suggesting that life beyond us is not only possible but perhaps likely. At the same time, their stories return us to Earth's earliest chapters. Our planet, young and violent, brimmed with volcanic activity, acidic oceans, and relentless bombardment. Yet even then, life emerged. Extremophiles may carry those ancient strategies, passed down through unbroken chains of existence. In studying them, we may be glimpsing not just survival but our own beginnings. There is also beauty in their persistence. Halophiles coloring salt lakes into shades of crimson, psychrophiles glimmering beneath sheets of ice, thermophiles thriving in rainbow pools. All create worlds within worlds, places that appear alien yet are entirely our own. Through them, we see that survival and beauty are not separate. They often coexist, quietly painting the landscapes we overlook. As night deepens, let your thoughts rest on these images. A desiccation-tolerant cell curled into stillness, waiting decades for a single drop of rain. A piezophile drifting in the silent depths, pressure its constant companion. An endolith hidden within rock, untouched by sunlight yet alive. And a halophile turning barren plains into seas of color. Each one tells us the same truth. Life does not need kindness to endure. It does not demand perfect balance or gentle climates. It only asks for possibility. And possibility, once found, is enough. So as you drift deeper into calm, let this truth settle. In the harshest deserts, in the darkest seas, in the most toxic pools, existence persists. Life in all its forms whispers through extremes, reminding us of resilience beyond measure. The more we explore the hidden lives of extremophiles, the more a single truth rises to the surface. Survival is not an act of defiance but an act of harmony. Each adaptation is not a fight against the environment but an embrace of it. Where we see danger, they see design. Where we see impossibility, they see home. Let us journey now to the blistering salt mines of Erevan. Within these crystalline caverns, light refracts in dazzling colors, bouncing across walls like shards of glass. Here, halophiles continue their quiet existence, bathing in concentrations of salt that would desiccate most cells instantly. Their membranes, finely tuned, manage osmotic balance with precision, allowing water to be retained even as the world around them pulls it away. To the human eye, the pools within these mines shimmer red and violet, painted by pigments the organisms produce. Yet these colors are not mere beauty. They shield against harsh sunlight and harness energy in ways unique to their chemistry. What we see as artistry is, for them, armor. Now consider the alkaline waters of Lake Dromar, where pH levels climb so high that most proteins unravel instantly. Alkaliphiles thrive here, their enzymes adapted to maintain function in the midst of caustic conditions. To them, a lake that burns human skin is not destructive but sustaining. Their success in such extremes has not gone unnoticed. Industries borrow their enzymes for detergents, where performance in high alkalinity is essential. From a remote alkaline shore, innovations ripple outward into homes across the world. Yet extremophiles are not only examples of survival, they are lessons in patience. In the deserts of Ovaris, desiccation-tolerant microbes rest for decades, sealed in silence. Without water, their cells shrink into near lifelessness, their DNA folded and locked away. To an observer, they might appear dead. But when rain returns, rare and precious, they unfurl and awaken, resuming life as if no years had passed. This extraordinary pause reflects resilience not through action but through stillness. Life here is not about movement or growth, but about endurance in waiting. In their quiet patience, we see that survival does not always roar. Sometimes it whispers, sometimes it waits, and sometimes it simply endures. From silence and stillness, let us plunge into sound and motion, the hydrothermal vents of the deep sea. Here, in the pitch-black waters of the ocean floor, Towering chimneys spew mineral-rich fluids, glowing faintly in the darkness. The pressure is immense, the heat intense, yet these vents host flourishing ecosystems built upon chemosynthetic extremophiles. These microbes consume sulfur and iron, transforming poison into sustenance. They are the foundation of an entire food web, supporting strange and wondrous creatures, giant tube worms, blind crabs, and glowing fish. Without extremophiles, these ecosystems would collapse, for in the absence of sunlight, chemical energy becomes life's foundation. It is almost poetic that what we see as wasteland, nature sees as fertile. The vents are not graveyards of fire and darkness, but gardens, nourished by the smallest of beings. This redefinition of limits is repeated in the story of radiation-resistant microbes. Where death is expected, life continues. Their ability to repair shattered DNA, to rebuild their very identity, is not simply survival, it is renewal. Through them, we learn that endings may sometimes be beginnings, that destruction can be rewritten into continuity. The practical implications extend far. Perhaps one day these organisms will help us clean nuclear waste, protect explorers on distant planets, or preserve fragile human tissues. What seems like a curiosity today may become a cornerstone tomorrow. Even more striking is the thought that these creatures are not outliers but reminders. Early Earth was extreme, filled with volcanic fire, acidic seas, and meteor strikes. For life to begin at all, it had to endure hostility. Extremophiles, then, are not the exceptions, they are echoes of our origins. Their endurance is not unusual, it is ancestral. To study them is to glimpse the beginning of the story we are still writing. It is to peer backward into time, to see how resilience gave rise to complexity, and to recognize that we are children of survival. Beyond Earth, extremophiles reshape our search for life. No longer do we confine possibility to planets resembling our own. Instead, we look to frozen moons, arid deserts, and subterranean oceans. If life thrives here, in places we once deemed barren, then surely it may thrive elsewhere. Consider the icy crust of Europa, beneath which lies a global ocean. Could microbes like those at Earth's hydrothermal vents survive there? Consider Mars, with its ancient riverbeds and subsurface ice. Could desiccation-tolerant organisms lie dormant beneath its dust, waiting for moisture? Each extremophile found here widens the map of possibility beyond Earth, turning our gaze outward with renewed hope. In the stillness of the night, let these thoughts rest in your imagination. A halophile glowing within crimson salt pools, an alkalyphyl breathing in caustic waters, a desiccated cell awakening after decades of silence, a microbe deep within the ocean, feasting on minerals beneath crushing weight, and a radiation-resistant bacterium quietly piecing itself together after devastation. Each image whispers a truth both simple and profound. Existence is not fragile glass waiting to shatter. It is living stone, weathered, reshaped, and unbroken. As you breathe deeply and settle into calm, know this. Resilience surrounds us, in forms both small and unseen. And if life can thrive in extremes, then so too can we, in our own struggles and storms. When we speak of extremophiles, we are not simply describing strange organisms. We are telling the story of endurance, of how life bends, stretches, and reshapes itself until survival is possible. Each one is a quiet reminder that possibility exists even in places where we imagine none. Picture the volcanic plains of Neirath, where rivers of molten stone once flowed and steam still rises from cracks in the earth. In these steaming vents, thermophiles continue their existence, building their lives in heat that would dissolve most proteins instantly. Their enzymes, refined through endless cycles of adaptation, do not falter in boiling conditions. Instead, they flourish, each reaction humming with efficiency at temperatures beyond ordinary comprehension. From one such heat dweller came a gift to humanity, the enzyme that powers the polymerase chain reaction, a process so vital to biology that it reshaped medicine, forensics, and genetic research. A creature invisible to the naked eye, thriving in boiling pools, became the key to unlocking the code of life itself. It is humbling to remember that discovery. Not far from fire lies the realm of ice. Travel with your thoughts to the frozen valleys of Serene, where glaciers carve their slow path across mountains, and winds howl like voices of the past. Beneath layers of snow and ice, psychrophiles remain alive, perfectly at ease in temperatures that paralyze most living things. Their antifreeze proteins protect them, preventing lethal crystals from forming inside. To them, the cold is not an enemy but a companion. They are adapted not in spite of the cold but because of it. Their strategies echo in laboratories now, as researchers explore how such proteins may help preserve food, protect crops from frost, or even safeguard human tissues during storage. What began as simple endurance in nature becomes inspiration for progress. Shift now to the desert plateaus of Karath, where the land cracks with thirst and rain may not fall for decades. In such stillness, desiccation-tolerant organisms lie dormant, their bodies curled inward, their DNA shielded by sugars and proteins. To the eye, they appear lifeless, indistinguishable from dust. But when the skies finally yield water, they awaken, carrying on as though time itself has bent around them. In their patience is a lesson that survival is not always about action, but about waiting with quiet resilience. Life here measures not in days or seasons, but in centuries of stillness followed by moments of awakening. This theme of resilience carries us into the crushing depths of the ocean. Imagine descending into the abyss of Vellora's seas, where sunlight never reaches and pressure would flatten ordinary forms. Here, pisophiles thrive, their very structure shaped to withstand the ocean's relentless weight. They feed on minerals from hydrothermal vents, forming the foundation of entire deep-sea ecosystems. In this alien darkness, glowing fish drift, crabs scuttle blindly, and tube worms bloom in radiant plumes. All of it begins with extremophiles, weaving sustenance from sulfur and iron. In these depths, where humans see desolation, nature writes symphonies of survival. It is a reminder that extremes are not barriers. They are stages upon which life performs its most astonishing acts. Even radiation, one of nature's fiercest destroyers, cannot silence all existence. Microbes like Deinococcus radiodurans accept devastation and rebuild from it, their DNA reassembled as though no harm was ever done. They reveal that survival is not the absence of destruction, but the mastery of recovery. Such creatures invite us to imagine the future. Perhaps one day their abilities will aid astronauts on long journeys, crops enduring harsh climates, or treatments that shield us from disease. The smallest organisms may one day provide solutions to humanity's largest challenges. Yet even beyond practical benefit, there is wonder. Extremophiles reshape our imagination, teaching us that what we call inhospitable is only inhospitable to us. They broaden our perspective of habitability, reminding us that life's conditions are not narrow but vast, not fragile but flexible. This flexibility is central to our search for life beyond Earth. On Mars, locked beneath dust and ice, could desiccation-tolerant organisms lie dormant? On Europa, beneath its frozen crust, could microbes thrive in mineral-rich oceans? On Enceladus, within its icy plumes, could chemotrophs drift, feasting on hidden minerals? Each extremophile found here on Earth adds weight to these questions, tilting possibility toward hope. Even in places as remote as the Atropha caves of Velmyra, where toxic gases fill the air and light never enters, microbes cling to stone, metabolizing minerals unseen. If they can thrive there, why not in caves beneath alien soil? And so, extremophiles connect us not only to our past but also to our future. They are bridges, spanning from Earth's fiery origins to the distant possibility of life elsewhere. In them, the story of existence expands beyond our small corner of the cosmos. As you breathe softly and let rest settle in, picture these marvels. A microbe basking in boiling water, its enzymes thriving where others would fail. A cell frozen in ice, unshaken, its antifreeze proteins keeping it safe. A dormant organism waiting decades for rain, rising once more when droplets finally fall. A bacterium in darkness repairing itself after radiation has shattered it. Each image reminds us of resilience, not as struggle but as transformation. Life does not resist the extremes, it becomes them. And in that transformation lies the truest lesson of all. Existence is vast, versatile, and endlessly persistent. To explore extremophiles is to explore possibility itself. Each one reminds us that survival is not limited to gentle conditions, nor bound to familiar rules. Where we expect absence, we find abundance. Where we assume silence, life hums with quiet persistence. Let us begin in the sulfur springs of Drovian Valley, where the air carries a sharp metallic scent and the waters steam with acidic strength. In these pools, acidophils flourish. Their cell walls and inner chemistry are finely adapted to resist corrosive assault. They do not merely endure the acid, they depend upon it. To them, the environment that strips metals bare is nourishment, a place to thrive. Their presence transforms desolation into vibrancy. What appears hostile to us is, for them, a garden. Their enzymes, operating in such acidic waters, are now studied for industrial uses, from biomining metals to breaking down pollutants. Once again, survival at the edge becomes inspiration for invention. Now shift to the soda lakes of Taran Basin, where alkalinity rises so high it scalds skin and dissolves most organic material. Alkaliphiles have mastered this environment, their enzymes and membranes attuned to harmony within basic waters. Their adaptations are no less astonishing than those of acidophils. Both extremes reveal that life can stretch its chemistry to embrace contradiction. From these alkaline dwellers, science has drawn enzymes used in detergents and cleaners, industries where performance in caustic solutions is necessary. They serve as a reminder that even in apparent wastelands, the groundwork for innovation lies waiting. Consider next the silent endurance of organisms that thrive on radiation. In places where energy bursts through with destructive force, life has found a way not merely to resist, but to rebuild. Their DNA repair systems are so precise that what we consider devastation becomes a temporary pause. Through them, we are forced to reconsider what damage truly means, for they transform ruin into continuation. This endurance leads naturally to another group, those living within stone itself. Endoliths are hidden from sight, embedded in cracks and pores of rocks, feeding slowly on minerals, existing in the stillness of geological time. Their lives move at a pace that defies our sense of urgency. What seems lifeless to us is, in truth, a realm of quiet activity. In their persistence, endoliths remind us that life does not require light, soil, or water in abundance. Sometimes survival means carving existence into stone, hidden yet steady. These varied strategies echo in the story of early Earth. When our planet was still young, molten, acidic, struck by constant impacts, it was not a gentle cradle. Yet life began. The extremophiles of today may carry within them those ancient lessons, unchanged over billions of years. To study them is to peer into history's deepest chapters, glimpsing how the first sparks of existence may have endured. And it is precisely because of their endurance that our search for extraterrestrial life has changed. Once, scientists believed we must look for worlds resembling our own, mild climates, temperate waters, breathable air. Now we know better. Extremophiles show that habitability does not require familiarity. It requires adaptability. So when we think of Mars, its surface barren and dry, we imagine desiccation-tolerant organisms waiting beneath the dust. When we picture Europa, its crust of ice hiding vast oceans below, we see chemotrophs feeding on minerals from hydrothermal vents. When we envision Enceladus, plumes bursting into space, we wonder whether microbial life drifts in its hidden seas. Every extremophile here extends possibility there. Each discovery on Earth expands our imagination beyond it, yet their importance lies not only in other worlds but also in our own. Industries already borrow their adaptations. Enzymes from thermophiles for molecular biology, from alkaliphiles for cleaning agents, from acidophils for mining. Medicine looks to their resilience for healing, preservation, and defense against disease. Agriculture dreams of crops fortified with their strength. The smallest of creatures shape the largest of possibilities. There is also quiet beauty in their presence. Imagine a salt plain bathed in evening sun, its surface reflecting crimson and violet hues created by halophiles. Picture a glacier glowing blue under moonlight, psychrophiles alive within the ice. Envision a vent in the deep sea, surrounded by organisms built upon the work of extremophiles. Each one turns desolation into wonder, hostility into spectacle. As night deepens and rest approaches, let your thoughts linger on these images. A microbe in acid, thriving where others would dissolve. An organism in a soda lake, its proteins steady in caustic waters. A cell within stone, invisible yet persistent. A radiation-resistant bacterium stitching itself back together. And in frozen silence, a psychrophile waiting beneath ice. Every image tells the same truth. Life is not fragile glass ready to shatter. It is resilience given form. It is adaptation made visible. It is possibility unfolding in silence and extremes. And so, as your breathing slows and calm surrounds you, let this truth settle deeply. Where we see emptiness, life sees opportunity. Where we see finality, life writes continuation. And where we believe silence reigns, existence whispers endlessly. Life, as shown by extremophiles, thrives not because conditions are gentle but because conditions challenge it. Survival is not resistance alone. It is transformation. Each organism becomes a reflection of the extreme it inhabits, woven seamlessly into its environment. Let us walk into the barren salt flats of Morath, where the land stretches in cracked white plains beneath an unrelenting sun. Here halophiles endure. In waters saturated with salt crystals, their pigments shimmer in red and violet hues, coloring entire pools as though painted by an unseen hand. To us, salt is desolation. To them, it is life. Their adaptations are not simple. Special pumps and proteins regulate the balance of ions inside their cells, preventing collapse in environments where water is drawn away relentlessly. They are masterpieces of molecular engineering, designed not by intention but by persistence. Now descend into the shadows of the Atropha caverns, where sunlight never penetrates and the air carries the sharp bite of sulfur. Within these darkness-bound chambers live chemolithotrophs, organisms that draw energy not from light but from rock itself. By metabolizing iron, sulfur, or hydrogen, they unlock energy hidden in stone. Where most life would starve, they feast. In them, we glimpse echoes of a distant Earth, when the planet was young and sunlight had not yet become life's universal currency. To study them is to study our origins, to see how existence can begin in shadows, powered not by light but by minerals beneath the surface. From shadow to fire. Journey next to the molten edges of volcanic fields in Serath, where rivers of lava carve their way through black stone. At the margins of these flows, where heat is nearly unbearable, thermophiles make their home. Their proteins refuse to unravel in the face of searing temperatures, holding their shape and function with remarkable strength. Out of one such organism came a tool that reshaped modern science, the enzyme that made DNA amplification possible. A reminder that breakthroughs often come not from comfort but from extremity. From boiling pools came precision, and from extremophiles came discovery. Now shift to the polar reaches of Talvin, where silence rules beneath endless ice. Psychrophiles here drift through frozen waters, shielded by proteins that resist crystallization. Where others would freeze and fracture, they remain supple and alive. Their strategies, so subtle yet effective, inspire scientists to preserve food, protect crops, and even extend the safe storage of human tissues. Imagine them as silent guardians beneath glacial walls, existing where time seems frozen, yet carrying on their quiet work. The desert wastes of Drelmer remind us of another form of survival, patience. Here, desiccation-tolerant microbes curl into dormancy, their metabolic activity nearly gone, their DNA folded and shielded by sugars. They may rest for decades, waiting, until the sky finally releases a rare rainfall. At that moment, with astonishing speed, they revive, their cells swelling with water, life resuming as if no pause had occurred. This ability is almost like stepping outside time. For humans, years pass with unrelenting force. For these organisms, decades are but a moment of stillness. Their lesson is quiet but profound. Endurance may be less about action and more about persistence in waiting. Now, let us dive into the deepest oceans. Beneath crushing weight, in absolute darkness, pisophiles thrive. Their cell membranes remain fluid and functional even under pressures that would destroy ordinary structures. They are architects of resilience, sculpted by pressure into forms both delicate and unyielding. Around them, ecosystems flourish, fueled by chemical energy released from hydrothermal vents. Here, life blooms in isolation, proof that sunlight is not the sole giver of energy. Even in darkness, where we expect emptiness, there is abundance. Among these organisms, the boundaries of what is normal blur. We are reminded again that habitability is not defined by our own comfort, but by the capacity of life to adapt. Radiation-resistant microbes deepen this lesson. For them, exposure to levels of radiation thousands of times stronger than lethal doses for humans is not an end, but an inconvenience. Their DNA repair systems piece together shattered genomes with astonishing accuracy. What seems like devastation becomes temporary disruption. If such resilience can be harnessed, it may one day protect explorers venturing into space, workers handling nuclear material, or even patients undergoing harsh treatments. Once again, survival at the edge may inspire hope in our own vulnerabilities. Beyond utility, these extremophiles reshape imagination. They allow us to envision life on worlds that seem alien. A barren Martian desert, a frozen ocean beneath Europa's crust, the hidden seas of Enceladus. Each once thought inhospitable, each now reimagined through the resilience we see here. If salt plains can bloom with halophiles, why not Martian soil? If microbes thrive beneath Antarctic ice, why not Europa's seas? If organisms metabolize stone in caves, why not within alien rock? Each discovery here stretches the boundary of possibility there. Even in the calm of night, let these images rest in your thoughts. A crimson salt pond shimmering under the sun, its colors born of halophiles. A dark cave alive with stone-feeding microbes. A volcanic spring brimming with thermophiles. A glacier hiding psychrophiles, their antifreeze proteins keeping them safe. A desert where dormant cells wait patiently for rain. A deep-sea vent alive with pisophiles, chemotrophs, and strange creatures, and a microbe bathed in radiation quietly piecing itself together. Each is a miracle, not because it defies nature, but because it defines it. Life in every form teaches us that possibility is broader than our imagination. So, as your eyes grow heavy and calmness settles in, remember this truth. Existence is not fragile. It is versatile, persistent, and endlessly inventive. Where we see barriers, life sees doors. Where we believe in silence, life continues its quiet song. Every corner of Earth whispers the same story. Life finds a way. Sometimes it shouts through vibrant colors. Sometimes it hums in stillness, but always it persists. The extremophiles remind us that existence is not brittle. It is endlessly resourceful. Let us wander first into the boiling springs of Calreth, where clouds of steam rise into the morning air. The water bubbles, its heat fierce enough to scald at the touch, yet here thermophiles dwell with ease. Their proteins are so finely crafted that they remain stable, resisting the chaos of high temperatures. In these pools, chemistry does not collapse, it thrives. From these creatures came one of the greatest gifts to modern science, the enzyme that allows DNA to be copied millions of times in a matter of hours. What was once hidden in a hot spring became a cornerstone of biology, medicine, and forensics. This single contribution reminds us that extremophiles do not just survive, they enrich all of us in ways unimaginable. Shift now to the frozen wilderness of Brivora, where ice stretches endlessly, broken only by the occasional black stone peak. Here, in waters so cold they should paralyze, psychrophiles thrive. Their secret lies in antifreeze proteins that prevent lethal crystals from forming inside them. Where most cells would rupture, theirs remain safe, flexible, and alive. For these organisms, cold is not a hindrance but a foundation. They turn frozen stillness into opportunity. And in doing so, they inspire technologies that may one day preserve human tissues for long journeys, protect crops against frost, or extend the freshness of food. Their survival becomes our progress. Travel farther to the deserts of Sarath, where silence reigns and rain is a rare gift. In the dust, desiccation-tolerant microbes curl into stillness, nearly shutting down all activity. They can rest like this for years, even decades. To an observer, they appear lifeless. But when the sky finally yields water, they awaken instantly, resuming their existence as if time had only paused. This is survival in its most poetic form. Not resistance, not struggle, but patience. The desert's lesson is that endurance may come not through constant effort but through stillness, through waiting until the moment is right. Now picture the great salt basins of Drovemere, where the ground glitters under the sun and pools of brine reflect hues of crimson and violet. Here, halophiles reign, thriving in salinity that would desiccate most cells. Their pigments, striking and vivid, not only protect them from sunlight but create breathtaking landscapes. To us, it is beauty. To them, it is survival. Their enzymes and cell structures balance salt with precision, refusing collapse in environments hostile to nearly all else. Humanity now studies these same enzymes for potential use in food preservation and industrial processes. Once again, extremophiles become silent partners in our own innovation. Deep beneath the earth in the caverns of Ithara, endoliths carve their quiet existence. Hidden in pores of stone, they feed on minerals, their lifespans measured not in days but in geologic ages. To us, stone is lifeless. To them, it is shelter and sustenance. Their presence expands our idea of where life can exist, reminding us that what appears barren may simply be unseen. Further still, in the ocean's abyss, the story continues. At hydrothermal vents, where mineral-rich waters surge from the Earth's crust, chemosynthetic extremophiles transform poison into sustenance. They form the base of ecosystems in darkness, sustaining tube worms, crabs, and glowing fish. Without them, the vents would be wastelands. With them, they become flourishing kingdoms of life. From lightless depths to sun-baked deserts, from acidic pools to alkaline lakes, extremophiles weave the same truth. Conditions we label as impossible are, for them, perfect. Their very existence asks us to reconsider what life truly requires. This reconsideration stretches our gaze beyond Earth. Mars, once thought dead, now tempts scientists with traces of ancient rivers and hidden ice. Could desiccation-tolerant microbes like those of Sarath's deserts lie dormant beneath its soil, waiting? Europa, with oceans locked beneath ice, may harbor chemosynthetic organisms like those at Earth's vents. Enceladus, spraying plumes into space, could hide life within its subsurface seas. Our search for extraterrestrial existence is shaped directly by extremophiles. They have expanded our imagination, teaching us that habitability does not mean comfort. It means adaptability. Consider the radiation-resistant microbes like Deinococcus radiodurans. Their ability to repair shattered DNA suggests that life could endure even on planets bathed in cosmic rays. If survival is possible here under such intensity, why not on the surface of distant worlds exposed to solar storms? These ideas are no longer dreams but scientific pursuits. Extremophiles have changed the very way we ask the question of life in the universe. No longer do we seek Earth clones, we seek extremes, knowing that life may already dwell there. And still, they influence not only our cosmic searches but our daily lives. The enzymes from thermophiles serve in labs worldwide. The strategies of psychrophiles aid food preservation. Halophiles inform salt-tolerant crops. Acidophils inspire biomining. Radiation-resistant microbes may one day protect humans in space. Each adaptation, once thought strange, is now a tool. What once was curiosity has become necessity. In the quiet of night, let these images linger in your thoughts. A hot spring bubbling, filled with unseen thermophiles. A frozen lake alive with psychrophiles beneath the ice. A desert where life rests for decades, waiting for rain. A salt plain glowing crimson with halophiles. A cavern where microbes feed on stone. A vent in the ocean erupting with minerals, life blooming in the darkness. And a microbe silently repairing itself after radiation tears it apart. Each picture is not just survival, it is brilliance. Not just persistence, it is creativity. Life in its smallest forms tells us that limits are illusions, boundaries bend, possibilities expand. And in every hostile corner of Earth, existence quietly thrives. So, as calmness settles and rest draws near, remember this. Resilience is not a rare miracle. It is life's constant truth. And if extremophiles endure in silence and extremes, then so too can we in our storms and shadows. The world of extremophiles is not merely a tale of survival. It is a mirror held up to existence itself, reflecting the boundless creativity of life. To dwell among them in thought is to witness endurance written in 1,000 forms, each one defying what we believe possible. Let us return to the volcanic ridges of Selmer, where smoke rises from fissures in the ground, and the air carries the sting of sulfur. Around these vents, thermophiles flourish, creatures to whom boiling water is not destruction but harmony. Their enzymes remain steady, folded against collapse, creating the perfect balance for life at high heat. It is strange to imagine, but for them, calm lies not in comfort but in fire. From their resilience, humanity has drawn knowledge. The enzyme that revolutionized genetics came from such a creature, forever binding the story of extremophiles with our own. A small organism in a hot pool transformed the speed of discovery, a reminder that greatness often comes quietly from the unseen. Now picture the frozen seas of Drathen, where ice stretches unbroken across the horizon, and silence holds the world in stillness. Beneath that thick, glassy crust, psychrophiles drift and feed, unharmed by cold that stills nearly all others. Their survival comes from proteins that keep their inner water liquid, a shield against freezing death. To them, cold is no enemy, it is the very rhythm of life. Scientists study these silent survivors, hoping to adapt their secrets. In frozen proteins may lie the key to longer preservation of medicines, safer food storage, or even aid for long journeys through the stars, where supplies must endure. Once again, life's strategy in one world becomes a possibility for another. Shift next to the deserts of Orales, where sand stretches endlessly and the wind carries only heat. In this stillness, desiccation-tolerant organisms endure in slumber, curling in on themselves, pausing their activity until the rains return. Decades may pass, yet they awaken instantly when water touches them. To call them patient is not enough. They are proof that existence can pause time, waiting until the world turns once more in their favor. How remarkable it is to imagine lying dormant through storms, through centuries, only to rise as if no moment had passed. In their patience lies a wisdom that speaks beyond science. Survival is not always resistance. Sometimes it is quiet waiting. From dryness, we journey to the salt-saturated lands of Voromir. In pools so thick with crystals they gleam beneath the sun, halophiles breathe easily. They bend light into vivid reds and purples, their pigments both shield and beauty. Entire lakes glow with their presence, landscapes transformed by their survival. In these microbes, enzymes balance salt pressure with delicate precision. What would destroy most cells sustains them. These adaptations are already serving humanity in preservation, biotechnology, and even medicine. Again, what thrives in extremity becomes guide for us. Travel farther still, into the caverns of Orithas. Deep in the stone, away from the warmth of sunlight, endoliths carve their lives into mineral walls. They grow slowly, consuming the tiniest traces of energy, yet persist over millennia. Invisible to the casual eye, they teach that life does not need vast resources. It only needs persistence. Imagine holding a rock in your hand, unaware that life hums quietly within it. Their existence asks us to expand our vision of what alive truly means. And then, beyond stone into ocean darkness. At the bottom of the seas, where pressure would crush steel and light never reaches, hydrothermal vents roar. Out of these chimneys, minerals stream forth, feeding entire kingdoms of creatures. At their foundation stand extremophiles, microbes that transform poison into nourishment. They weave energy from sulfur and iron, building worlds in the dark. It is humbling to realize that ecosystems so rich, so strange, depend on beings too small to see. From vents of fire come communities that defy imagination, sustained not by sunlight but by chemistry itself. Their lessons extend far beyond Earth. On Europa, beneath its ice, similar vents may surge. On Enceladus, plumes bursting into space may hide chemotrophic life. Extremophiles on our world are not simply curiosities, they are blueprints for where else life may be found. Radiation, too, cannot halt existence. Consider Deinococcus radiodurans, a bacterium that reassembles its shattered DNA with precision, piecing itself together after blasts that would obliterate human cells. To it, radiation is not destruction, but a challenge met with patience and repair. It shows us that survival can mean not avoiding harm but mending after it. Such organisms remind us that endurance does not look the same everywhere. For some it is heat, for others ice. For some it is patience, for others rebuilding. In each strategy lies a reflection of life's unyielding creativity. These strategies have not gone unnoticed by humanity. Industries borrow enzymes from thermophiles, detergents harness alkaliphiles, mining turns to acidophils, preservation studies psychrophiles. The future may yet lean upon their resilience for food, medicine, and survival beyond Earth. But beyond their usefulness there is awe, awe in crimson salt lakes, awe in glacial silence, awe in the fire-lit vents of the sea, awe in creatures that live unseen in stone, awe in cells that rest for centuries, then awaken as if from a dream, awe in DNA reassembled after destruction. Their presence tells us this. Life is not fragile glass waiting to break. It is iron woven into silk, unyielding yet graceful, adapting to every blow. So as rest draws near and your breath slows, picture them, thermophiles in steaming pools, psychrophiles beneath blue ice, halophiles turning water crimson, desert microbes wading through decades, endoliths carving into stone, chemotrophs feeding in black seas, radiation-resistant microbes piecing themselves back together. They are not anomalies, they are proof. Proof that existence bends but does not break. Proof that resilience is not rare, it is the essence of life. And so, may their quiet endurance settle into your thoughts as you drift. Just as they thrive in their extremes, you too can endure in yours. To reflect on extremophiles is to recognize that life's story is broader than we once believed. These creatures, whether hidden in the cracks of stone, dwelling in volcanic fire, or suspended in desert silence, reshape our understanding of what it means to exist. Consider again the fiery pools of Torithas, their surfaces churning with steam, the air heavy with minerals. To humans, stepping into such heat would mean certain harm. Yet for thermophiles, this is balance, their proteins finely tuned to function where nearly all else would fail. In those boiling depths, they live not in spite of the heat but because of it. Their very definition of comfort redefines ours. From this heat came more than survival. The polymerase that revolutionized genetic science was born here. From one microbe's adaptation came a tool that allowed humanity to duplicate DNA with speed and precision. It is not exaggeration to say that medicine, forensics, and even evolutionary research are forever changed because of that discovery. From fire we move to frost. The glacial expanses of Neurath hold their own quiet kingdoms. Beneath the sheets of ice, psychrophiles endure temperatures that should freeze cells solid. Yet their inner world remains liquid, their proteins designed to prevent crystallization. Their lives move slowly, deliberately, yet persist with strength. Imagine drifting through waters so cold that silence itself seems physical, yet remaining alive, each breath, each division of a cell a triumph. For us, such conditions mean lifelessness. For them, it is simply home. Their adaptations have sparked human technologies too, helping preserve delicate materials and extending the storage of food. Their survival becomes our possibility. Now wander the deserts of Salvaran, where the sky burns with heat and water is almost myth. Here, microbes shrink into dormancy, reducing life to its simplest form. Decades pass, storms rage, yet they remain waiting. And when the rain finally comes, even in a single drop, they revive instantly, swelling with renewed life. There is something profoundly poetic in their existence. It is not merely endurance, it is timelessness. To sleep through centuries and awaken as if no second had passed is to embody patience itself. For them, survival is not struggle. It is stillness, readiness, trust that the rain will one day fall. From dryness to salinity, the salt flats of Kareth shimmer under a punishing sun. Pools glitter with hues of crimson and violet, pigments of halophiles staining entire landscapes. These microbes revel in what would desiccate most others, managing internal balance with astonishing precision. The beauty they create is not decoration but defense, pigments that shield them from harsh light. Yet in defending themselves, they transform the land into wonders that inspire awe. Humanity now studies them for their enzymes, seeking ways to use their strength in preservation and industry. In extremity, beauty and practicality blend. Beneath mountains, in the unseen hollows of stone, endoliths whisper a slower story. Carving out lives in mineral pores, they grow at a pace nearly incomprehensible to human thought. To touch a rock is to hold both geology and biology, stone and life together. What appears lifeless reveals quiet existence. They remind us that even the most barren-seeming places may hold secrets. Life's reach is not just wide but deep, embedding itself where no one thought to look. In the abyss of the ocean, hydrothermal vents roar, plumes of minerals rising like pillars in the darkness. Here, chemosynthetic microbes perform a miracle, feeding not on light but on chemicals. They transform poison into food, building foundations for ecosystems bursting with strange life. Tube worms, blind crabs, glowing fish. It is astonishing that entire worlds can exist in lightless depths, born of fire and mineral breath. Without microbes, there would be no such kingdoms. Their survival becomes the architecture of an entire ecosystem, a reminder that even darkness can hold abundance. Across Earth, extremophiles carve these lessons again and again. That life is adaptable, that conditions are relative, that survival is invention. From the scalding to the frozen, from the acidic to the alkaline, from the irradiated to the pressurized, life creates strategies that seem miraculous but are, in truth, natural. Their presence inspires us to look outward. Mars, with its scarred deserts, may hide dormant microbes awaiting thaw. Europa's seas beneath ice may echo our own vents, hiding ecosystems that drift in mineral-fed abundance. Enceladus, with its geysers spraying into space, might shelter life in waters like those psychrophiles endure here. And further still, planets orbiting distant stars may hold environments we cannot yet imagine. Extremophiles remind us to broaden our view, not to ask where Earth-like conditions are, but to ask instead, where might any condition nurture life? Radiation-resistant microbes sharpen this thought. On worlds bathed in cosmic rays, on surfaces scorched by solar winds, life may yet persist, repairing itself as it does here. Existence is not fragile, it is adaptive. Humanity now follows their example in practice. From labs to industries, extremophiles lend their resilience. Thermophiles gift enzymes to science. Psychrophiles teach preservation. Halophiles inspire crop research. Acidophiles guide mining. Radiation-resistant microbes may shield space explorers. Their lessons move from curiosity into utility, shaping progress across fields. But more than what they give, they teach wonder. Crimson pools glowing under a relentless sun. Glaciers hiding quiet kingdoms beneath their ice. Deserts where microbes slumber through centuries. Stones cradling life in silence. Vents in darkness exploding with vitality. Each one says, life is not fragile glass waiting to shatter. It is strong, adaptable, infinitely creative. Extremophiles are not exceptions. They are confirmations that resilience is life's rule. So as night settles and your thoughts grow gentle, picture them once more. Thermophiles breathing in heat, psychrophiles dancing beneath ice, halophiles painting salt flats, desert microbes awaiting rain, endoliths dwelling within stone, chemotrophs feeding in black oceans, radiation-resistant microbes piecing their genomes back together. In every vision lies the same truth. Life bends, it shifts, it waits, but it does not vanish. Let this truth accompany you into rest, that the universe is more hospitable than it seems, because life does not need ease, only opportunity. To drift into the world of extremophiles is to drift into endless imagination. Each one is a fragment of proof, showing that survival is never a single path but 1,000 different strategies. In their quiet ways, they rewrite the rules of existence, reminding us that life is not bound to comfort. It is bound only to possibility. Picture first the boiling pools of Vathra, the water rising in rolling bubbles, steam thick in the air. To us it is danger, to thermophiles it is sanctuary. Their enzymes do not unravel here, they reach their peak. For them this is not hostile, it is home. Their story has already changed ours, for it was from such organisms that science drew the enzyme, now powering countless discoveries in genetics. From hidden pools came a cornerstone of modern research. Shift from fire to ice, where the silent glaciers of Xyrilland spread endlessly under dim skies. Beneath their frozen surface, psychrophiles move slowly, cells flexible against the cold, proteins guarding against the danger of crystal formation. In conditions we would call unlivable, they carry on their delicate lives. To them, the cold is rhythm, not threat. Their adaptations ripple into human practice, teaching us to preserve fragile materials longer, to imagine food and medicine lasting across years of storage. Their quiet endurance becomes the seed of our own resilience. From the ice, let us step into the dry, endless deserts of Salmorath. Here the ground cracks, the air burns, and rain is a forgotten guest. Yet organisms here fold themselves into dormancy, shrinking, waiting, nearly lifeless to the eye. They rest through storms, through ages, through centuries even, until water at last returns. Then, as if no time has passed, they awaken and resume their existence. This patience is not weakness but triumph. It tells us that sometimes strength is stillness, that survival may lie in waiting for the right moment. The desert's silence becomes a lesson in time itself. Next, the great salt basins of Orenvale shimmer beneath the relentless sun, colors bleeding into crimson and violet. Halophiles thrive here, their pigments doubling as protection and beauty, transforming pools into works of art. They balance internal pressure with perfect skill, surviving where salt would destroy nearly all others. Their brilliance is both practical and awe-inspiring. What looks like a glowing lake to us is, for them, a thriving kingdom. Humanity now draws upon their enzymes for preservation and production, yet beyond usefulness lies the sheer wonder of their existence. Deeper still, in the stone chambers of Narthis, endoliths live in shadows unseen. Within the smallest pores of rock, they take sustenance from minerals, persisting with a patience measured not in years but in geological ages. In their stillness lies a reminder: what we call barren may in truth be alive. And beneath the ocean's crushing pressure, vents burst forth with mineral plumes, creating havens in the dark. Chemosynthetic microbes gather here, transforming elements into energy, weaving food chains that sustain entire ecosystems. In utter darkness, life blossoms because of them, tube worms and blind crabs drawing existence from their invisible work. The thought that entire worlds rest upon their ability to convert poison into sustenance humbles us. They remind us that ecosystems are built not from grandeur, but from the smallest beginnings. Radiation, too, fails to silence life. Deinococcus radiodurans has become a symbol of this truth. Its DNA may shatter under cosmic blasts, but it rebuilds itself with precision, reforming what was broken. To it, radiation is not the end, but a puzzle solved again and again. It suggests that life might exist even on worlds flooded with radiation, planets where we once thought no cell could survive. If here such organisms endure, then elsewhere they may endure too. This vision expands our search for life beyond Earth. On Mars, with its ancient rivers now dry, dormant microbes may yet rest, waiting for water's return. On Europa, seas beneath ice may harbor chemotrophic life like our own vents. On Enceladus, geysers may release traces of organisms from hidden oceans. Extremophiles teach us to ask wider questions, to seek not only Earth-like havens but extremes themselves. They are guides not just for discovery but for innovation. Thermophiles lend enzymes to labs. Psychrophiles hint at preservation technologies. Halophiles offer insight into salt-tolerant crops. Acidophils help extract minerals through biomining. Radiation-resistant microbes may aid human journeys into space. Each adaptation becomes a lesson, each survival a tool. But beyond their practical value is their poetry. Crimson pools glowing under a merciless sun. Glaciers hiding slow-moving kingdoms beneath their frozen skins. Deserts holding life in secret slumber for decades. Rocks humming with unseen existence. Oceans in darkness roaring with chemical-born vitality. Cells repairing themselves after devastation. Each one whispers that life is not fragile. It bends, it pauses, it rebuilds, but it does not vanish. It thrives in silence, in extremes, in impossibility. As you rest, let these visions ease into your mind. Thermophiles dancing in steam, psychrophiles gliding under ice, halophiles coloring salt lakes, desert microbes curling into waiting silence, endoliths deep in stone, chemotrophs blooming in black seas, radiation-resistant microbes piecing their essence together. They are not exceptions to life's rule. They are the rule itself, proof that resilience is the foundation of existence. And so, may their endurance soothe you, a reminder that in every harsh place, life not only survives but flourishes. To listen closely to the lessons of extremophiles is to realize that resilience is not rare but universal. They are not curiosities on the edge of existence. They are signposts of what life truly is: unrelenting, adaptable, endlessly inventive. Consider again the volcanic pools of Tivaris, surfaces bubbling, vapors rising, the air thick with minerals. In that furnace, thermophiles thrive, their enzymes operating with precision where heat would unravel nearly all others. For them, the boiling is calm, the scalding is peace. From their cells came tools that reshaped human science, proving once more that in fire, possibility takes form. Then to the frozen reaches of Myronholt, where ice stretches in endless plains, the horizon sharp and still. Beneath its glass-like crust, psychrophiles persist, their proteins tuned to prevent ice from piercing them. Their lives are measured not in haste but in quiet continuance, drifting in waters too cold for nearly anything else. What we call inhospitable, they call home. And from their secret exists a gift, methods for keeping delicate things intact, medicine stored, food preserved, life stretched across time. Next, turn to the parched deserts of Athamir. For miles the land is cracked, the air heavy with heat, water a rarity whispered on the wind. Here, organisms fold inwards, slowing until they are almost nothing. Yet they are not gone, they are waiting. Years may pass, even centuries, but when a drop of water falls, they stir again, swelling back into motion. Their patience is more than endurance. It is trust in time. They embody the truth that survival does not always demand constant struggle. Sometimes it lies in stillness, in faith that change will come. From silence to brilliance, we step into the salt flats of Lethra, where pools shimmer crimson, violet, and gold. Halophiles reign here, their pigments both armor and artistry. They shift entire landscapes with their colors, weaving beauty out of necessity. Their enzymes hold the balance against overwhelming salinity, teaching us to imagine crops and systems that can endure in places where salt claims dominion. To look upon these glowing lakes is to see the world transformed not by human hand, but by organisms too small to notice at first glance. Yet they paint the land in strokes seen from the skies. Beneath mountains, in chambers that echo with silence, endoliths mark their presence. Living inside stone, feeding on minerals, they grow so slowly that time seems irrelevant. A pebble might hold them unseen, life etched into rock without announcement. They remind us that what seems lifeless may in truth be alive, that existence is not always visible to the eye. And then, far below oceans, where pressure crushes and light is absent, vents erupt with fire and minerals. From these chimneys, extremophiles build entire worlds. Chemotrophs take poison and make it sustenance, weaving chains of life that climb upward, sustaining creatures strange and luminous. In absolute darkness, ecosystems flourish because of them, proving again that energy can be drawn not only from the sun but from the heart of Earth itself. These hidden architects challenge our vision of life beyond this planet. If they can thrive here, why not elsewhere? On the icy oceans of Europa, on the geyser-speckled surface of Enceladus, in the ancient valleys of Mars, or in worlds still unimagined circling distant suns, such life may already persist. Extremophiles broaden the search, reminding us to look not only for comfort but for possibility. Radiation, too, long feared as absolute destruction, is no end to some. Deinococcus radiodurans rewrites its shattered genome with precision, reforming itself again and again after cosmic blasts. It shows us that survival is not avoidance, it is rebuilding. It whispers that even under stars that burn too harshly, life could exist, repairing itself endlessly beneath skies of radiation. Across every extreme, one truth repeats. Life bends, it adapts, it waits, it rebuilds. It does not surrender easily. Extremophiles are not mere exceptions, but constant reminders that existence itself is tenacious. Humanity has already borrowed from their strength. Thermophiles gave science its replicating tools. Psychrophiles suggest preservation that stretches beyond years. Halophiles promise crops and processes in salted lands. Acidophils aid in drawing minerals from stone. Radiation-tolerant microbes may one day guard explorers on other worlds. With each adaptation, we find inspiration for our own progress. But beyond what they give, there is wonder. The crimson glow of salt pools stretching to the horizon. The silent pulse of life beneath ice. The patience of desert microbes sleeping through centuries. The secret whispers of endoliths within rock. The flourishing of vents in the dark seas. The reassembly of genomes torn apart by blasts. Each vision is a reminder. Life is not fragile. It does not shatter at the first strike. It bends, pauses, paints, builds, waits, rebuilds. It persists. So as the quiet settles, let these images linger. Thermophiles dancing in heat, psychrophiles gliding under glaciers, halophiles staining water in colors of dawn, desert microbes waiting with timeless patience, endoliths breathing within stone, chemotrophs weaving ecosystems in darkness, radiation-resistant bacteria mending their essence. They are the chorus of existence, voices from extremes that declare the same truth. Survival is not rare. It is the essence of life itself. And with that thought, may your own rest be guided, not by fear of what is harsh, but by recognition that endurance is always possible. Extremophiles remind us that the definition of habitable is far wider than we once believed. For much of human history, we thought life required the same conditions we rely upon: temperate climates, fresh water, gentle air. Yet time and discovery have revealed a larger truth. Life's reach is vast, extending into heat, cold, acid, salt, stone, and even radiation. In the volcanic pools of Drevant, heat shimmers upward, water boiling and air thick with sulfur. To humans, this is ruin. To thermophiles, it is nourishment. Their enzymes turn fire into balance, transforming destruction into comfort. From them, humanity drew one of the greatest tools in genetic research, reshaping science forever. Fire became knowledge, and knowledge became progress. Far from fire, the frozen lands of Ilarith stretch in endless stillness. Beneath glaciers, psychrophiles survive where cold bites hardest, their proteins resisting crystallization, their lives steady in silence. For them, what is unbearable to us is serenity. Their endurance inspires human attempts to preserve food, medicine, and delicate materials across vast spans of time. The cold that stills most things becomes, for them, continuity. In the deserts of Narath, life folds into itself, shrinking nearly to invisibility. The ground is parched, the air a furnace, and yet organisms endure by waiting. They rest through centuries, through storms, through emptiness. Then, with the faintest drop of water, they awaken fully, as if no time had passed. They are patience given form, proof that survival is not only struggle but also trust in what lies ahead. From silence we move to brilliance. The salt flats of Elmaris, painted in scarlet and violet by halophiles. What might desiccate all other cells is joy to them. Their pigments defend, their balance sustains, and in doing so they create beauty seen across horizons. Humanity now looks to their enzymes for answers in preservation, industry, and agriculture. Yet their greatest gift is wonder, a landscape colored by survival itself. Beneath mountain stone, hidden in crevices and pores, endoliths carve their existence. Feeding on minerals, growing slowly beyond our sense of time, they whisper that rock itself can cradle life. What seems barren often holds secrets. To hold a stone may be to hold a universe of unseen organisms, existing with patience older than memory. And below the oceans, at vents where fire meets water, chemosynthetic microbes work their transformations. With no light to guide them, they build ecosystems out of minerals and chemical breath. Entire communities of strange and luminous creatures rise because of them. Where there is no sun, life thrives by another path. Darkness does not mean emptiness. Even radiation, long thought to mark an absolute limit, is not final. Deinococcus radiodurans survives cosmic blasts, piecing its DNA together after it shatters, as though destruction were only interruption. It suggests that even in space, on worlds drenched in radiation, existence may persist. For them, devastation is not the end. It is merely a pause. Together, these beings redefine our search for life beyond Earth. On Mars, microbes may rest in its ancient soil, waiting for warmth. On Europa, oceans beneath ice may echo our vents, sustaining entire unseen kingdoms. On Enceladus, plumes bursting into space may carry whispers of life from its hidden seas. Across countless stars, extremophiles expand possibility. No longer do we ask where life might be like ours. We ask where life, in any form, might simply endure. Humanity has already begun to learn from them. Thermophiles gave science the ability to replicate DNA at will. Psychrophiles guide us in preservation. Halophiles show how to endure in salt. Acidophils and alkaliphiles offer industry and extraction. Radiation-resistant microbes hint at protection for journeys through space. Their adaptations become our inspiration, their endurance our path forward. But beyond use lies meaning. To see crimson pools shining under a punishing sun, to imagine life beneath glaciers, to picture organisms slumbering through centuries of desert silence, to remember that even stone carries breath. These are visions that remind us that existence is not fragile. It is not delicate glass ready to crack. It is strength hidden in smallness, persistence written in the tiniest forms. Extremophiles do not merely survive, they flourish. They wait, they paint, they build, they mend. They teach us that life does not require ease, only opportunity. So as you rest, let their stories drift with you. Thermophiles rising in steam, psychrophiles gliding in frozen waters, halophiles tinting lakes in colors of dawn, desert microbes waiting endlessly, then blooming with rain, endoliths breathing within stone, chemotrophs weaving life in black oceans, radiation-resistant bacteria piecing their essence back together. Each one whispers the same message. Existence endures. It bends, it pauses, it rebuilds, but it does not fade. And may that truth guide your thoughts tonight, that wherever the universe stretches, wherever stars burn and shadows fall, life in some form may already be waiting, resilient, patient, enduring. For in the end, extremophiles are not the exception to the story of life. They are the story.